102.2 Auckland. The Radio Wammo Breakfast.
Kiwi.
Dylan Storey's Astronomy. Dylan Storey is back to talk astronomy with us this morning. Amateur astronomy, really, though he's, I would say he's a bit of a pro because he hangs out at the Auckland Stardom Observatory. G'day there, Dylan.
Hey, Wammo.
I'm the amateur around here.
Yeah, I wouldn't quite call myself a pro. I don't know, somewhere in between. When I go and talk to the real astronomers, that's when I feel like an amateur.
Yeah, true. We're always learning, of course. Now, hey, Dylan, I managed to get a telescope this week. There's a new phone, a Samsung phone. It's called the Galaxy S. It's been released, but rather than hand out phones, they decided to hand out telescopes. Of course, with the whole
phones, telescopes,
yeah.
Yeah. I can see the link.
Yeah, well, I guess it's with the whole Galaxy name, and so it's got the Samsung Galaxy S on the side of it. But it's essentially a Tesco telescope, and to me, it's quite impressive. I mean, I've never owned a telescope before, and so this is quite exciting. The fact that I might be able to go and stare into the night sky and actually see something for once.
Yeah, and you will. It should be quite good. I mean, but I'm a telescope snob.
Yeah.
So Tesco wouldn't be my first stopping point.
Okay, I should have known that there's some kind of hierarchy with telescopes out there.
There's a lot of elitism in the telescope world.
Yeah, no doubt.
You'll have a good time with that.
Yeah, I think so. Now, I put it together. That was exciting, putting it together. But then there's a whole lot of parts that came with it, like little lenses and stuff, and I had a look at the instruction book, and I'm like, oh, man, I don't know where to start with this thing.
Well, I can see it on the screen there. Is it Lego?
Is it Lego? Yeah, it could be Lego. No, it's
No, it looks like a refractor telescope.
Okay, what does that mean?
That means you've basically got lenses. It's basically like a magnifying glass, and your eyepiece is situated at the focal point of the lens.
Okay, well, and so at the end where your eye looks in, I've got a whole lot of attachments that I can put in, and right into the end, and various kind of lenses, and they've got names for them as well.
Yeah, you'll probably have a couple of eyepieces which will provide extra magnification. Mm-hmm. So for looking a wide field of view, you'll have a higher number, something like 20 or 30 millimeter eyepiece. That'll give you quite a wide field of view for looking at things like open clusters.
I've got something here called a Barlow lens. What's that?
Barlow is like a little adapter lens where you can put it'll give you a little bit of extra magnification on top of you put it in between the lens and the telescope, and it just gives you a little bit of a booster.
Okay, and also something called a erecting eyepiece. Goodness me, an erecting eyepiece.
Erecting, yeah. Well, eyepiece. I'm not sure what the erecting is for, but yeah, that's the bit you put in the end to look through. So you've got different magnifications of those, which will boost the telescope magnification. And
I've also got an elbow-looking piece, which means that you don't have to crouch all the way down underneath the telescope. You can kind of look down.
Yeah, that's right. If you're looking at something that's vertically up in the sky, you don't really want to be.
And then also in various little containers, I've got the little the actual lenses that you look through, and I guess each one is a different kind of magnification.
That's right. The smaller number, the higher the magnification. So if you want to zoom right in on something, you might have something as small as a 4 millimeter lens or 10 millimeter. Whereas if you want a wider field of view, you'll have sort of 20, 30 mil.
Oh, okay, so and so the lens will actually look bigger as well. Like that's bigger than.
Yes, the smaller number will look smaller, but it will give you the biggest magnification.
Okay,
if that makes sense.
Okay. And why would you want to use different magnification? I mean, surely you'd always want to have the most powerful magnification. Surely you'd always want to get as close as possible.
Well, not necessarily, because if you're looking at something that's quite wide in diameter, such as the moon or an open cluster, if you zoom right in, you're only going to see one tiny little part of it. So you do want a wider field of view for that.
Yeah.
Or you could use the wider field of view for locating something.
Yep.
And then then use the higher magnification for looking in more detail. Let's say a globular cluster or something. But if you look at the moon through a 4mm lens with a decent telescope, you're only going to see a tiny little segment. But if you want to sort of get more of a breathtaking view of the whole moon, then you'd use the wider lens. Of course, it depends on the size of the telescope too.
Yeah. Now, I mean, not all telescopes created equal, obviously, Dylan.
No.
Also, I thought this was kind of flash because on top of it, it's got something called like a little star finder that's got a little battery inside it. And apparently that's what you look through first to see what area of the night sky you want. And then there's a little red dot. When you switch it on, there's a little red dot that you can place over the object in the sky. And
okay, so it's basically just a flash sort of crosshairs.
Yeah, basically.
They normally have a crosshairs. Yeah, so it's like you sight them in like a rifle. So in the day you find a landmark through the main scope, and then you adjust the finder scope so the crosshairs or the dot are right on it.
Okay. And
then when you go out at night, you find something, because you'll often be so zoomed in that it'll just be impossible to find your way around the sky with the main scope. So you use the finder scope, put the crosshairs on it, then look through the main scope, and it'll be right on it.
And I'd imagine when you do that, you'd need to tighten every kind of screw on here so that the thing doesn't move at all once you've got it zoomed in.
Yeah, that's right. Problem with that type of mount is it looks like what we call an alt-az mount, altitude azimuth, so you're moving around the horizon and up and down.
Yes.
So that's a really good, for a beginner, it's a sort of good intuitive way of finding things in the sky. You can easily move those telescope movements to point at what you want. The problem is with those mounts, if you want to look at anything for any length of time, that the turning of the world is pretty quickly going to take it out of the field of view.
Of course, yeah.
So they're a kind of good starting off telescope, and the other style I would recommend is called a Dobsonian.
Okay.
Which are basically like that, but they're bigger. Yeah, there we go. They're
And describe what that looks like.
It's like a big barrel attached to the ground on a mounting system, and it's got the eyepiece up the top. That's because it's a different kind of telescope. It's a reflector instead of a refractor.
Mm-hmm.
So instead of having a lens like a magnifying glass, you've got a mirror down the end, and that mirror's collecting the light and sending it back up the tube, collecting it on a smaller mirror and sending it out to your eyepiece. So you've got this big tube, and you kind of basically look in the top, and the same sort of movements, you can move it around the horizon and up and down. And so that's a great starting out serious telescope.
Okay, so that would still be something that enthusiasts would have at home.
Absolutely, yeah. Okay. When I got into astronomy, I hired an 8-inch Dobsonian.
Okay, and what would you move up to from there?
Well, if you want to look at anything for any length of time, which if you're sort of giving something some serious study, or if you want to take pictures of it, then you need a different mounting system that's going to be able to track it across the sky. So you need what we call an equatorial mount, and that is set up so it's going to have, you're going to set up the angle of it exactly so it points at the south celestial pole from wherever your latitude is, and that means that as something moves across the sky as time goes on, as the world turns, that one of the axes on that mounting system is going to track it. So you can either turn the little handle there, which will follow it along.
Yep.
Or if you want to get more serious, if you want to take photos, if you want to attach your camera to it, you can buy a tracking motor which hooks onto the little axle of that turning wheel, and will basically compensate for the turning of the Earth, so you can keep it permanently pointed at something.
And depending on where you were using this, and you attached a camera to it, could you take photos that had, like, those cloudy colours and those not exactly like Hubble takes, but close to that sort of multicoloured, amazing, beautiful space scene?
Basically, no, unless you've got a really flash camera set up.
Right.
The thing is, those pictures you see in space, they're artificially coloured, but they're accurately artificially coloured. So, for example, Hubble will take a picture in infrared of a nebula or something, and then it will take the results of that and it will colour them red. You'll get a black and white image basically, but you'll get a black and white image of the red emitting part of the object. and so artificially colour that red. So it's kind of like a spruced up version of what the human eye could see, or what the human eye could see if it was right up by it.
Right.
It is actually accurate, but no, you wouldn't see that through a telescope. You'll see a black and white image. But if you wanted to get really serious about it, you could get various filters for your camera and take different pictures through different filters and artificially colour them and layer them.
Okay. So
it's quite a big process in astrophotography.
So how much would this equatorial telescope set you back?
I think you can get something like a 6-inch or an 8-inch for around $600 or $800.
Oh, that's a lot cheaper than I thought.
I might even have a price.
I was thinking in the thousands.
No. Let me see. I got the price of the 8-inch or 12-inch Dobsonian is that's $1,600.
Okay.
But you can get a 8-inch Dobsonian there for $800, which that would be my if I was starting out in astronomy, that would be my starting place basically.
Yeah, one of those.
Because that's a really good. You can see some really cool things through that.
Okay, well,
and it's easy to use.
Talking about seeing something, if I was to pop out this weekend during the storm and look into the sky.
If you can find a break in the storm,
yeah.
And actually that can actually be the best time to view, because when you've got all that moisture in the air, the storm actually clears a lot of the humidity out of the upper atmosphere. So in between thunder and rainstorms, and you actually get the clearest skies sometimes.
Cool.
So what I'd advise you to do would be go out after about 8:30 or 9,
yep.
and look to the east. You'll see something very bright, brighter than anything else.
Yep.
And that's the planet Jupiter. You'll have Venus as well in the west after sunset, which will also be very bright. Venus will be more white in colour. Jupiter will have a more sort of yellowish hue. And through that telescope of yours, you should be able to see 4 of its moons.
Wow!
Up to 4 of its moons. So, like the picture on the screen, for anyone looking at the screen, you'll see the large circular shape of Jupiter in the centre. Then you might see up to 4 dots in a line, one or both sides of it. So those are the 4 Galilean moons, Jupiter's 4 biggest moons. That
will be incredible if I'm able to actually see some moons from another planet. That is...
It is incredible, yeah. And they're what Galileo saw through his telescope, it must be 500 years ago now.
Yeah.
And that was... He concluded that there were these things orbiting something that wasn't the Earth, and that was one of the main key points that led him to overturning the Church's theory that everything was going around the sun, around the Earth.
Crikey. Well, look out for me. I will be taking on the elements on one of Auckland's volcanic cones this
Yep.
this weekend. Hey, Dylan, thanks for running through some basics of telescopes with us. I'm sure that there is, golly gosh, a whole lot more to it than that. No doubt.
Yeah, you can get right into it. Stardome do hold telescope sessions as part of their shows.
Cool.
After the 8 o'clock show, there's some great telescope viewing, and they also sell the aforementioned Dobsonian telescopes.
Oh, great.
There's a sample of those in the shop for anyone wanting to get started.
Choice. Thanks very much, Dylan.
No worries.
Same time next week, of course. Dylan's...
Yeah, we'll find something amazing about space to talk about next week.
No doubt. I might have my own story as well by then.
Oh, yeah.
All right.